Okay guys, so in this video I'm going to talk about triangles and you know ways to find areas of triangles, how to find sides of a triangle, and how to find angles of triangles. Okay, so let's get started with the basic idea of what a triangle is. Well, a triangle is unique in the manner that it looks like this. It's basically, it can be categorized as half of a square. And obviously right now I drew a special triangle, which is known as your 90 degrees triangle. So let's start with the degrees of a triangle. There are 180 degrees in a triangle, right? So we know that because of this, that that you can, if angles that exist in the triangle, then you can figure out what corresponding angles have to be. So let's say I wrote this. Let's say we'll just do a mock example right now. So let's say we have 3, 4, and 5. These are our the sides of our triangles, and we want to figure out what the degrees here is and the degrees here is. Okay, so what will we do here? Basically, this is where I'm introducing the law of sines. Law of sines. Now, what does the law of sines say? The law of sines says that there has to be a proportion within a triangle such that the sine of, let's say we have side, that the corresponding angle to a side, let's say that side is A, has to be equal to the proportion of the angle opposite to another side, let's say B. So this is the law of sines. And what the law of sines says is that if we know side, if we either know, let's say we know an angle of one of the sides, and we know both sides, we can find the angle of the other side. Or we can say that if we know both angles and one of the sides, we can find the other side. So you can manipulate this algebraically to obtain a lot of information, actually. And let me actually label this. So let's say that this is side A, this is side B, and this is side C. So basically, from the law of sines, what this says is that if we have, let's say we want to find this angle right here, right? We'll call this small b. This is typically how we'll call this small c. This is small b. This is small a. This is typically how you denote angles, because if you have a side A, that its corresponding angle that's opposite of it has to be the lowercase version. So what do we do here? What we do is we basically write down the law of sines. We know here this is a 90-degree angle, right? We know that this is a 90-degree angle. So we know that sine of 90 over 5 has to equal, now let's look at the situation of let's look at small b. So we know that this is equal to sine of b all over 3. So we know that from this picture, one second, we know that that 3/5 sine 90 has to equal sine of b. So we know that we can simplify this. We know that sine of 90 is 1, so we know that sine b has to equal 3/5, right? So all you do here is you basically, you just grab your calculator, make sure it's in, you'd want it in degrees for this situation unless you want it to convert to radians. So if you converted this, and you found out what b would have to be, you'd find out the degrees that b would have to be. You'd figure out that, let's say, we'll go to 2 decimal places. So we know that b has to equal 36.86 degrees. Okay? And we already knew that what C was equal to 90 degrees. So what do we expect? And this is going to prove our geometry to us. What do we expect A would equal? Well, A would have to equal, obviously we know that there's 180 degrees in a triangle. So we know that basically it would have to be what's left of what the possible angles there could be in a triangle. So we would have to figure out what that final side is. We know what it already has to be, but let's prove what it will have to be, because we know that there has to be 180 degrees in a triangle. So let's do it again. Let's use that same side. You don't have to do this. We can say sine of 90 and over 5, and then we'll say sine of A, and the side that corresponded to A was 4. So we know from here that basically, I'll do it quick, but that sine 90 is 1, and you bring over that 4, so we know that 4/5 equals sine A. So when you do this and you do it out, you find out that A has to equal 53.13. Okay? So let's see what we have here, right? We have 53.13 there. And this should be very equal or extremely close to our 180 degrees, because we know that there's 180 degrees in a triangle. So, this is what, let's add this. Okay, so 9, 9, 9, 1, 1, 7. So 179.99. And we know that there's, so it would be this guy. This guy can go up. That could have been rounded one more spot, but yeah, this is extremely close. And you're probably asking, why isn't it not exact? Well, we basically messed with, fractions, and some of these fractions, they go on for a very long time. They don't terminate very easily, and basically that's why we have that very small margin of error. But we know, because because this should have been 0.87, I didn't round properly. That was where we got that last 0.1. So yes, we did just get our identity that that in that triangle, that 3, 4, 5 triangle, that these have to be the corresponding degrees of it. Yeah, so that's how you can find, the degrees of, the degrees of angles in a triangle. But you have to know at least 2 sides of the triangle and 1 angle that's corresponding to it to find out another angle. Like if you had some sort of situation where, you know, you had a triangle, let's say, and I know that this is right, but let's say for all instances this was not a right angle, and we knew that this was 4, 3, and 5 again, but we know that this guy isn't a right angle. So what does that mean? Well, actually, that would go into law of cosines, but let's assume that let's say we did assume that this was a right angle, right? So if we did assume that was a right angle and we tried to use law of cosines, we wouldn't be able to figure it out because we wouldn't know two sides and one of the angles that is opposite of one of the sides, so we couldn't do law of sines. So now I think it's important to show the Pythagorean theorem, basically how you can find, you know, you can find sides of a triangle. Basically, and I'll make a nice correlation here between the Pythagorean theorem and the law of sines. I mean, not the law of cosines are actually the same thing, and you don't even know it. But I'll prove to you why they are the same thing in a little bit. So basically, you know, you have your Pythagorean theorem. It says that a squared plus b squared equals c squared. Now, why does this hold true? This says that the two legs of a right triangle has to be equal to the square. Well, the squares of the two legs added together must be the square of the hypotenuse. So let me show you the basic situation. You know, we knew that we had two legs in the previous triangle that were 3 and 4 and a hypotenuse of 5. So let's see if that is true, if that triangle is indeed a right triangle. And let's see, so we have 3 squared plus 4 squared equals c squared. So we have 25 equals c squared. So you square root both sides, and you'll see that c equals 5. So yes, that was actually a right triangle, and we knew that was going to be a right triangle because the squares of the sides added together equals the square of the hypotenuse. So basically, that method of finding sides is only unique to right triangles. Like if I had a unique triangle, let's say, and it wasn't a right triangle, let's say something like this, and I knew, you know, two sides, this side would not be this side would not be, you know, would not be 5 because of this special angle here, and this angle is important to us. And this is where I'm going to go into the law of cosines now. Now, the law of cosines, basically, the idea of that is that, you know, and it will look very similar, and you might be able to see this, why it is like this. C squared equals a squared plus b squared plus 2, I mean, not plus, that's subtract. That has to be minus 2ab cosine c, lowercase c. Now, why does this idea hold true, you might ask? Why, you know, why does this work? And you might see something here. You might see, wait, there's a little bit of the Pythagorean theorem here. You see the Pythagorean theorem right here, but what's this last little part doing here? Well, now let me talk about, as you remember before, I said, you know, the little letter that goes, the little letter that corresponds to the big letter represents the angle of that big letter that is opposite of it. So if I wrote my triangle, let's say, let's look at the situation of, of the same triangle, the 4, 3, and 5. Let's look at that again. And let's just say that this was A, this was B, that was B, and that was C. Okay? So if we're going from this formula over here, the angle that corresponds with C, because we just saw that this is a right triangle, this is 90 degrees, isn't it? So if I write this right here, if I rewrite this, it would be C squared equals A squared plus B squared minus 2AB cosine 90. But what is cosine of 90? Cosine of 90, this is 0. So this whole thing's being multiplied together. That whole thing's just going to become 0. So what do we have left here? And why is this the formula for sides of a right triangle? That's because you're assuming that because it's a right triangle, the angle that is opposite of your hypotenuse is 90 degrees. So that's why you get this idea. Okay? So let's just do one. Let's say that we have a triangle. I don't know. And this is terrible. I don't know why this is happening. So let's say, hold on. Let's say that we have a triangle. Let's say that, and this is not going to be right. Let's say we have this guy. And I'm going to do, a similar situation to show you that this won't work out the same way as a right triangle. So let's say this is 3, and this is 4, and let's say the angle between them is, let's say it's 70 degrees. 70 degrees. Now let's find out what this hypotenuse, this C, would have to be. Okay? So what will we do here? We want to find C, so C squared, let's say this is A, this is B, so C squared equals 4 squared plus 3 squared minus 2 times 4 times 3 times cosine of 70. Okay? So let's simplify this then. So we know that we can do a good amount of simplifying here. So we know that this would be C squared equals 16 plus 9 minus 24 cosine of 70. So then if you do this out with your calculator, 1 second. So you figure out that, that C squared equals 8.69. So C would have to equal, hold on, crap, I messed that up. Whoopsie. Yeah, that seems better. Hold on. Okay, that seems a little bit better. So C squared equals 16.79. So if you take the square root of that, you get that C equals 4.09. So, what does this say, and what do we just show? That, we had the same legs in theory from our right triangle. We had the same legs in theory from our right triangle, but the angle between them was not 90, it was actually smaller. So that affected what our C was drastically. And this shows the idea was that the hypotenuse, your C, always has to be your biggest side. And one of our legs is 4, but our C is 4.09, which, isn't too much bigger than one of our legs, but it is bigger. So our concept of the hypotenuse being the biggest side holds true. So now I'll show you area of the two ways to write area of a triangle. Well, if you have a triangle, if you have a square, let's say, right? You know that the area of this has to be base times height. So area of a square equals base times height. Well, if we know that each one of these sides is a right angle, right? So if we were to split them right in half, okay? We know that the area would have to be 1/2 of that, 1/2 of that square. So the area of a triangle is 1/2 base times height. But that assumes that this triangle is a right triangle. Now let me show you the situation where you find the area of a triangle that is not a right triangle. So, and I'll show you two situations, one with a right triangle and one when it's not right. So let's say this was 3 and 4. So we know that this has to be 5, but I mean that's not very important, but we know that the right angle is 4. Now let's look at the same situation. Let's say something has, this looks right, but it won't be right. We have 3 and 4, and the angle between here is 70 degrees, okay? So what is the difference here? Well, you assume that, and this is the idea kind of that goes with the law of sines, but what you're writing here, when you write the formula for what you're doing here, and you don't even know it, the area for a triangle is 1/2 BH sine theta. So basically the area of a triangle is the base times the height times the angle that is between the base and the height. So, and why do we use this representation of the area? I mean, look at it this way. In the situation that in the situation that we have the right triangle, what is the angle between the base and the height? It's 90 degrees, right? And what's sine of 90? Sine of 90 is just 1. So you get this special situation for an equation for the area of a right triangle. Now, let me show you the situation when it's not. Let's have that same situation. If we have 1/2, and we said the sides were 4 and 3, and the angle between them was 70 degrees, right? So we know that if it was a 90-degree triangle, the area would be 6, right? Because this would be 1, so 4 times 3 is 12, and half of 12 is 6. Now let's see how much it changes when the angle between them actually gets smaller. So, so what happened here? Well, actually the area actually got smaller. This right here is equivalent to 5.64. So, and this would make sense, right? Because if the angle is getting smaller and smaller, let's say we look at the situation of, sine of 0. Sine of 0. Let's say that you had, this would basically mean that they were, they were basically on each other, so you would have no area at all, because you'd have basically, there would be no angle here. Like, this would be an angle, but if there's a sine angle of 0 between them, then there's no area at all. So that idea holds true as well. So basically what you should get out of this video is that you can figure out sides of a triangle with the Pythagorean theorem if it's a right triangle, and you can also figure out the area of a right triangle. But if you have a situation where you have triangles that you know are not right, you can figure out angles between them, or you can figure out their sides with the law of cosines, or you can find out the area with the special 1/2 AB sine theta. So yeah, this will be the end of this video, guys. Like and comment on what you think, and see you later.